Hello, this is Dr. Eddie Morgan at Clovis East High School, and I want to go over the homework help for worksheet 1.2b. Remember, for any problem you're working on the homework for worksheet 1.2b, if you're struggling, look at the corresponding problem on this PowerPoint. It'll show you a very similar problem, and if you look at how we solved this one, you should be able to go back and solve the other one. So, let's get started. Here we have an equation that often brings on what I call fraction brain freeze to my students. The moment they see a fraction, they immediately assume, I can't do this, it's a fraction. Well, we have a fraction buster. You can get rid of any equation, you can get rid of all the fractions by a simple trick. Simply find the common denominator between all the fractions and use that number and multiply it by all of the numbers. If we look at this equation, we have the numbers 4, 2, and 8. What's the greatest common denominator between 2, 4, and 8? Well, if I were to write this out, and this is a longhand, you probably can already see it. I recognize that 4 equals 2 times 2, and 2 equals 2, and 8 equals 2 times 2 times 2. Well, if I want to get them all, I'm going to have the 2 times 2 times 2 is 8. That's the greatest common denominator. All right. So what I need to do in this problem is I need to multiply everything on both sides by 8. So I can do this using the multiplication property of equality. Now when I distribute this through here, notice I'm going to get 8 times 3/4 minus 8 times m over 2 equals 8 times 1 over 8. Well, I can do a little simplification here. 8 divided by 4 is 2, so 2 times 3 is 6. 8 divided by 2 in this problem is 4, so this is going to be minus 4m equals 8 divided by 8 is 1 equals 1. Notice what we did. By simply multiplying by the greatest common denominator, we eliminated the whole fraction, and you're looking at this equation and going, I can do that one. Okay, so let's do it. So notice here, if you want to, this one sometimes gives students equations because the m is switched. I could rewrite this as minus 4m plus 6 if that helps you. You don't have to do it, but notice that what's really happening is m is being multiplied by negative 4 and then adding 6. So the thing we want to do first is get rid of the plus 6 by subtracting 6. So this is the addition property of equality. 6 minus 6 is 0, so we end up with minus 4m, and 1 minus 6 is negative 5. Okay, so we got a good job there. And now we want to undo this. So we undo negative 4 by negative 4 times m, we undo by dividing by negative 4. And we end up with m equals 5/4. And that's our answer. And here, of course, we did the division property of equality. The second problem is actually easier than the first in this respect, because if you notice here, all the equations have the same denominator. So the common denominator is simply 4. So we're going to multiply everything by 4, all right? And we can do that because of the multiplication property of equality. And so we have 4 times minus 5/4 r plus 4 times 7/4 r equals 4 times 1/4. Don't forget to multiply the other side. We're multiplying everything. Well, 4 divided by 4 is 1. So we end up with minus 5r plus, and again this cancel out, plus 7r, and 4 divided by 4 equals 1. Okay. So now we can combine like terms. 7r minus 5r is 2r equals 1. And now we can simply undo 2 times r by dividing by 2, both sides. And that's our division property. And we have r equals 1/2. And that's our answer. Problem 3, we have common denominators of 2 and 4. So to get all my factors there, my common denominator, my greatest common denominator is 4. So to eliminate the fractions, I'm going to multiply both sides by 4. And that's by the multiplication property of equality. So again, we have to distribute everything. So I have 4 times 7/2 x minus 4 times 2x equals, don't forget to multiply 4 to the other side as well. And 4 divided by 2 is 2, so I end up with 2 times 7, 14x. Here, 4 times 2 is minus 8x, and then 4 divided by 4 is 1 equals 5. So we have 14x minus 8x is 6x equals 5. And at this point, you see what we did here was we combined like terms. And now we undo 6 times x by dividing both sides by 6. That's the division property of equality. Six divided by 6 is 1, so we get x equals 5/6, and that's our answer. Once again, we want to eliminate the fractions by multiplying by the common denominator. My two numbers here are 6 and 4. So let's get the prime factors. 6 is 2 times 3, and 4 is 2 times, not another 3, but another 2. So if I look down here, I'm going to need 2 times 3 times 2, and so that ends up equaling 12. So to get rid of all these fractions, I'm going to need to multiply by 12, both sides. Okay, so let's do the distribution here. I have 12 times 7 over 6 on the left side of the equation, and that equals 12 times minus 3 over 4x plus 12 times 5 over 4x. So 12 divided by 6 is 2, so this is going to end up being 14. 12 divided by 4 here is 3, and so we have 3 times minus 3 is negative 9x. And then 12 divided by 4 is 3. 3 times 5 is 15x. By the way, we did this because we could use the multiplication property of equality. And now we notice that we can combine like terms. (15x minus 9x), so we get 14 equals 6x. Now we simply have a one-step equation. We undo x times 6 by dividing both sides by 6. This is the division property of equality. 6 divided by 6 is 1. So we end up with 14 over 6 equals x. Or we can turn that around and say x equals 14 divided by 6. This one, you notice that we can reduce because we can take a 2 out of each of them and actually get x equals 7/3. Or if you'd like, it's 2 1/3. In problem 5, we want to learn how to get rid of decimals, just like we got rid of fraction. Now, I'm going to show you something that may help you understand. If I were to write this equation as fractions instead of decimals, it would look like this. 1.86 is actually 1 and 86 hundredths. This is actually, if you read it, is 6/10 x. So this is 6/10 x. And then the last one, this is -3 and 54 hundredths. So if I read it correctly, I notice that I have a 10 and I have 100. So my greatest common denominator is 100. And if I would multiplied everything by 100, you see the 100 would go away there, and I would end up here with 186 plus 60x equals -354. However, you don't always have to look at the fraction part. You can look up here and just simply count the decimal points. This is 1 and 86 hundredths. I can look here and go, look, there's 1, 2 decimal points there. Here there's just 1, but here's there's 2, and pick the largest one. Well, the largest is 2, so I do a multiple of 2. It's going to be 2 times 10 it's going to be 10 times 10, or 100. So I'm going to use the multiplication property of equality. Just keep thinking about this fraction one and know you're always going to be in decimals multiplying by 10, 100, or 1,000. So let's multiply by 100. And 100 times 1.86 means the decimal moves over 2, and so I end up with 186. In the next one, if I move this over 2, notice that I get 60x, not 6, whereas here I'm going to get -354 because the decimal moves twice. So you see, multiplying by 10 moves it over 1, multiplying by 100 moves it over 2. That's why I picked the larger one. And now you see I have a two-step equation. So how do we do this? We undo the addition first. Notice I have plus 186. So we're going to subtract 186 from both sides. And this is the subtraction. Property of equality. So that goes away, and I have 60x equals, let's add these up, it's a negative, 6 and 4 is 10, 14,540. Now we'll undo the 60 times x by dividing by 60, and this is the division property of equality. $60 divided by 60 is 1. So I'm left with x equals a negative, and 60 goes into 54 9 times. So my answer is x equals 9. 6 is a fairly easy problem. I want to get rid of the decimals again, and I notice all I need to do, like here, is to move this over 1, 1, and 1. They're all the same. So to move the decimal over 1, that's going to be 1 factor of 10. So all I need to do is multiply both sides by 10. And we'll use the multiplication property of equality. That tells us that if two expressions are equal and I multiply them by the same number, they're going to stay equal. Now multiplying by 10 simply means move the decimal 1 to the right, so I end up with 13 equals 36 minus 7x. Fairly simple. And now we have a two-step equation. Now be careful here, because this minus goes with the -7. What I really have is a plus 36, so we want to undo the plus 36. So we're going to subtract 36 here from both sides. Remember, both sides of the equation. So this is the subtraction property of equality. So 13 minus 36 is going to be -23. This goes away, and I have minus 7x. All right? And now what we want to do is we want to undo the -7 times x by dividing by -7. This is the division property of equality. So 7 divided by 7 is 1. And we end up over here, negative by negative is positive. So we end up with 23 over 7, or we can reverse that and say that this is x equals 23 over 7. And that's our answer. Now the next one, again, we want to get rid of the decimal. So I notice here that in my first one I need to move that over 2 places or multiply by 100. Here only by 10, so we always pick the larger one. So let's use the multiplication property of equality. And multiply the whole equation by 100. Remember, we used the largest one. When I multiply this one here by 2, it moves over and this becomes 75. Now an important thing to understand here is this is a product here. And so when I multiply this product, I only have to multiply one of them. I don't have to multiply the d minus 16. That's enough there. I don't also go ahead and multiply it by that number. In other words, if I wanted to, if you said, what's 2 times 6? You'd say, oh, that's 12. But 6 is also 2 times 3. Now you see, what would happen if I went 2 times 2 and then went 2 times 3? You'd see I end up with 4 times 6. I'd end up with 24 because I actually multiplied it twice. So when you have this situation up here, you multiply the first number here to get rid of the decimal, but you don't do anything the other. Now over here, notice if I move 2, it's 1, 2, so this is actually 150. So be careful of that. When we only had to move a 1, but we're multiplying by 100. Now we're going to do the distributive property here to get rid of the parentheses. And let me get my calculator. What's 75 times 16? Ooh, that's 1200. And now we have a two-step equation. So let's undo the subtract 1200 by adding 1200. So that goes away, and I have 75d equals 1350. So now we'll undo this by dividing by 75. And we get that d equals, let me look at my calculator, 1350 divided by 75. And d equals 18, and there's my answer. So again, just to point out, remember that when I have two numbers multiplied together here, this and this expression, I only multiply the 100 times one part of it, not both parts. In problem 8, we just have to find which decimal has the most decimal digits to the right of the decimal point. You notice the first one only has 1, but this one has 1, 2, 3. This one has 2. So we want to do this one, which is 3, and that's going to be 10 times 10 times 10, or 1,000. So we're going to multiply everything by 1,000 to get rid of the decimal points. And again, of course, we're doing the multiplication property of equality. Now remember, when I multiply by 1,000, I'm actually going to move it over 1, 2, 3. So this actually becomes 500x. This becomes all the way over there, 2975. And this one, I'm moving over 3, so it's going to become 3750. Got to be a little careful there. With the ones that aren't fully off, you're going to end up adding an extra 0 there. So now, here's our two-step equation. We'll undo the subtract 2975 first by adding 2975. So here we have 5. 7 and 5 is 12, carry the 1, 17, carry the 1, 625. That goes away, and we have 500x. So now to solve that, we'll divide both sides by 500. And then let's do this, and we're going to use my calculator. 6725 divided by 500 equals 13.45. And there's our answer. Notice this equation. They say, suppose you want to solve this equation. I'm just going to write it down here in bigger so we can see it. And they're asking, what's the first thing you would do first? Well, obviously, we always talked about dividing it in two sides and see if we could simplify one side or the other. The right side simplified, but notice here we have like terms. So the answer to this equation is the first thing I would do is combine like terms. So the answer to this question, they don't even ask you to solve it. They just want to know what's the first thing you would do, and the answer is the first thing you would do is combine like terms. Then you would have a two-step equation and you would solve it in the normal way. This says to describe two ways to solve this problem. Well, the two ways I see immediately. First of all, you can solve it directly by just immediately going to the distributive property. So I'm going to have minus 1/3 times 6x minus 1/3 times 9, and that equals 18. So 3 goes into 6 2 times, so I have minus 2x, and then minus times a minus is plus. 3 goes into 9 3 times, plus 3 is going to equal 18. And now we have a two-step equation. Undo the plus 3 by subtracting 3. We get minus 2x equals 15. Then undo x times minus 2 by dividing by minus 2. And we end up with x equals negative 15 over halves. And that's one way. The other approach is to eliminate the fraction. And in this case, we would multiply both sides by a 3 to get rid of that 3. So I'm going to have 3 times minus 1/3 times 6x minus 9 equals 3 times 18. Remember, again, we only multiply this one time, this product. So that's 1. So we end up with minus 1 times 6x minus 9 equals 3 times this, 54. Distribute the negative. Negative 6x plus 9 equals 54. Subtract 9. And we get minus 6x equals 45. That goes away. Divide by minus 6. And we get x equals 45 divided by minus 6. And notice if I take a 3 out of each of these, I get 15 over 2, which is the same answer I got before. So those are the two ways you can do it. You can either just go straight distribution and solve it, or you could eliminate the fraction to begin with. And you just had to pick which way you think might be easier for you. The last problem is a word problem that's very common. It has to do with dining out and how much money can you spend. You notice it says that you're ordering a meal and you only have $20 to spend. Now there's a typo in this problem. If you look at the formula here, we actually are charging 6%. That's what the restaurant charges as sales tax. They take your bill and they add 6% to it. And you'll see here's that written down here. 6% is 6/100ths times X. That's going to be added to the bill. And then you'd like to leave a 15% tip, so you add another 1/1500ths times that. So they simply want us to solve this problem, and notice that they've given us the formula. So let's write down the formula. The cost is going to be the amount of the bill plus 6% of the bill, or 6/100ths, plus 15% of the bill, which is my tip. First thing I notice is that in this case I only have $20, so I'm going to substitute 20 in for C. Now at this point I could just add these up, realizing that this is x, so that's just 1x, 1 plus 600 plus 1500s. But you may say, hey, I don't like decimals, I want to get rid of them. So I look for the decimal with the largest number of digits, and I notice that both of these have 2 digits. So that means 10 times 10. If I multiply everything by 100, it will get rid of those decimals. So 100 times 20 is going to be 2,000. 100 times 1x is going to be 100x. And then here, by multiplying by 100, the decimals, this simply becomes 6x plus 15x. In my next step, I notice that all of these are x terms, so I can add them together. Combine like terms. 100 plus 6 plus 15 is 121x. And now we're going to solve for x. We undo x times 121 by dividing by 121. And we have that x equals, take out our calculator, 2,000 divided by 121 equals 16.5289. If I were to round off to the nearest penny, the 8's bigger than 10, so I round off. So I would say x is about $16.53. So the question is, what's the maximum amount I can spend on my meal? It would be $16.53. If I spend any more with the tip and the sales tax, it'll be more than $20. So if I stay, at under $16 or under, I'm going to be in good shape. All right. I hope this has helped you with your homework.